Good morning, everybody. So here we have a question on Form 5, Chapter 7, Quantum Physics. If you want to get the PDF version of the question, you can go to the go to the description section down below. So let's have a look at this question. Diagram 6 shows a graph of maximum kinetic energy, Kmax, against frequency F for metal P and metal Q. Okay, so here is a graph that shows you basically for each of these metals, what is the kinetic energy, what is the threshold frequency, and all that kind of stuff lah. Okay, so the threshold frequency FO and the work function W for each metal can be determined from the x-intercept and the y-intercept of the graph, and Kmax against F respectively. Okay, what is meant by threshold frequency? Okay, so threshold basically means a minimum. Okay, now why is there a minimum frequency here? Because when we talk about this topic, right, there's one very important thing you need to remember, which is the photoelectric effect. Okay, so what is a photoelectric effect? Basically, if you shine light onto a metal, excuse me, the metal will release electrons, okay, when you shine light on it. But not all light can cause the metal to release electrons, okay? The light actually needs to be above a specific frequency, which is basically this minimum frequency of the metal lah, okay? So the threshold frequency is basically the minimum frequency, you can write this, the minimum frequency that can cause what to happen? That can cause the photoelectric effect to happen, okay? That can produce photoelectric effect. Photoelectric effect on a metal, okay? Now, of course, you can also say it is the minimum frequency required for a metal to emit electrons. Yeah, that is also true, right? So that's the meaning of threshold frequency. Okay, the next question. Given that the Planck's constant h is this number, based on the diagram 6, calculate the work function for metal Q. Okay, so threshold frequency means minimum frequency, right? Work function actually means minimum energy. Okay, work function means minimum energy. Now, in case you didn't know, the energy of a photon is equals to h times f. Okay, so you can actually get this from the formula sheet as well, right? Over at this part. Okay, over here, right? Quantum physics, you can see E is equals to hf. So the minimum energy would also be equals to hf, where the f you're going to use the minimum frequency lah, which is a threshold frequency. Okay, now in fact there is a formula itself for the work function. Yeah, you can see these are actually the same formula. The work function is equals to hf, but fo here means threshold frequency. Okay, fo means threshold frequency. So you can write down W is equals to HFO. Now, H is 6.63 times 10 power negative 34. Okay, what about the threshold frequency for Q, metal Q? You just go back to the graph and you can see this here is the threshold frequency. Okay, how do I know this is the threshold frequency? First of all, they told you already. The threshold frequency can be determined from x-intercept. Work function from y-intercept, okay? So x-intercept meaning these 2 points lah. Okay, that's threshold frequency. Now, even if they never said this, you should also know that this is a threshold frequency because at this point, right, the Kmax meaning kinetic energy of electrons. Okay, remember just now we are releasing electrons, right? When we shine light, the electrons come up. Now, if let's say I want no extra energy for the electrons, okay? I'm just saying, I just want to release electron. I don't want to give my electrons any extra energy. I just want him to be released. So I will use exactly just enough for the electrons to come out, but no extra energy for the electrons. That's why the kinetic energy for electrons is 0. Okay, so 10.34 for metal Q, yeah, times 10, you can see here, this is times 10 to the power of 14. Okay, so if you put this into your calculator, right, 6.63 times 10 power negative 34 times 10.34 times 10 power 14. So you get 6.85542 times 10 to the power of negative 19. Okay, what is the units for work function? Like I said, it is energy, minimum energy. No matter what energy, kinetic, heat energy, light energy, they are all calculated in joules. Okay, that's the SI unit for energy. All right, next part. Based on diagram 6, compare the threshold frequency of the metal. So now you know already that this number is a threshold frequency. I can say P is lesser than Q lah. Okay, so threshold frequency of metal P is smaller than metal Q. Of course, you can say it the other way around. Threshold frequency of metal Q is greater than metal P. And for the work function, right, just now I mentioned, you look at the y-intercept, okay? The work function of P and the work function of Q. Now, be careful, huh? Don't think that because P is above, then it is greater. It is actually smaller because remember, this is 0. So this would be like -1, -2, -3, -4, and so on. Which means the lower down you go, the number actually gets bigger. Okay? So the work function for Q is actually greater than P. Okay? So you can say work function for of metal P is smaller than metal Q. Okay? Now the next one, the maximum kinetic energy of photoelectrons emitted from the metal surface. Okay, how to know what is the maximum kinetic energy of photoelectrons emitted from the metal surface? You just have a look at the graph, right? You can see that no matter what it is, okay, no matter which F you're looking at, what frequency you're looking at, P will always be above Q. Do you understand? So let's say, let me just extrapolate this a little bit. Okay, let's say at this frequency, Q will release this energy electron and P will release this energy electron. Okay? P will always be higher up than Q when it comes to the maximum kinetic energy. Okay? So no matter what frequency you're looking at, the maximum kinetic energy of photoelectrons from metal P is greater than metal Q. Okay? So of course, after we do any comparison question, we must always do a relate question. So based on the answer in 6C, relate the threshold frequency to the work function. Okay, so you just have to look at your answer just now. Threshold frequency for P is smaller, work function of P is smaller. So we can say the smaller the threshold frequency, the smaller the work function. Okay? Or you could also say it the other way around. The greater the threshold frequency, the greater the work function. Of course, it is also okay to say as the threshold frequency increases, the work function increases. Okay? The greater the threshold frequency, the greater the work function. Okay. As for the next one, relate the work function to the maximum kinetic energy of photoelectrons. Again, just look at your answers just now. Work function for P is smaller. Maximum kinetic energy for P is greater. Okay, so of course this would be the other an opposite relationship lah. So the greater the work function of the metal, the lesser the maximum kinetic energy. Okay, or as the work function increases, the maximum kinetic energy decreases. Okay, the greater the work function, the lesser the maximum kinetic energy of photoelectrons. Okay, so remember, photoelectrons are the electrons that are released due to photoelectric effect. Okay, when you shine light and the electrons come out, we call them photoelectrons. Okay, the last question. What happens to the electrons on the surface of metal P if a beam of light that has a frequency 6.64 times 10 to the power of 14 is directed at the surface of metal P? So 6.64 times 10 to the power of 14 is exactly the threshold frequency of metal P, which means it's exactly enough. Okay, it's just enough. So the electrons will be released. Okay, yeah, electrons will be emitted. You can say that. So photoelectrons, you can also use electrons only. Photoelectrons will be emitted from the surface. Okay, yeah. So basically, that is a very simple question on Form 5 Chapter 7. Now, if you learn something, yeah, make sure to like and subscribe. And if there's any more chapters or if you want to see more questions from the same chapters, just let me know in the comments below. Okay, I'll see you next time. Bye-bye.